to get this done in time, I'm going to go through it semi-slowly. If you can't follow along step by step, you'll have the video to refer back to. Definitely ask me if you have any questions, but if you get a little bit held up, then I'm going to keep going so that we can get through everything. It's a little bit complicated. It's a very complicated process, what you're being asked to do. So I'm going to try to explain it with as clearly as possible, but this is not beginner stuff. So, okay, so I've got my outlines. You guys understand how to make planes, right? So I've made planes in here. I'm going to get rid of this guy. I'm activating my planes layer, and I've got my endpoint snaps on. I'm going to use the surface 4 points to make, I'm going to use my surface 4 points to fill in the gaps on this opening. And now I've got surfaces in all of the places, right? If I turn it into rendered, you can see that I've got a closed polygonal shell, right?
So you're going to open one of those,
Mm-hmm.
close it to do this perforation or to unfold exercise? Does that make sense? If we're going to open up one place?
You can unfold something that has an opening in it, but I would do the perforations after, and I'll tell you why when we get to that point. So if you have like a window or a door or something, you can do that now. Okay, does everybody feel like they can get to that point if you have made all the surfaces or not? Okay, so that's what I'm doing just for ease of seeing. So let me describe what we're going to do. It's a bunch of different steps. So you've got this closed shell, right? What you need to do is a couple of different things. One is perforate it, and we've got a script to do that. And then the other is to set it up for laser cutting. So everybody understands that the laser cutter cuts vector files out of two-dimensional sheets of material, right? So this is a three-dimensional object. We have to figure out how to make it using two-dimensional planes and how to get the geometries all oriented so that they're laying down flat on a sheet, right? Everybody understand what we need to do generally? It's like making a dress pattern, cutting one of those out and turning it into three-dimensional shape, right? So fortunately, Rhino is smarter than we are. Rhino will take a lot of the manual labor out of this with a couple of different options that it has. So I'm going to put my layers back over here so that you can see them, or that I can see other things. Come on. So what I'm going to do is to have just my surfaces showing, and it's going to be really important that you keep everything on the right layer for this process to work. So I'm going to have everything selected, and I'm going to type in join. And that turns this into a, that turns this into a closed polysurface. The reason that we need it to be a closed polysurface is that we need it to be joined together with all of the surfaces understanding what connects to what, so that we can use a command in Rhino called unroll, which will take it and flatten it all out onto the ground plane. The other thing that we need to make sure that we have are flat planar facets, right? So we can't have something that's, like all of these are planar, meaning that they're not curving in two directions. So if you have like a sphere and you cut a section of it, right, that's curving in two directions, so it's not going to flatten or unroll that. So just be careful when you're making your surfaces that everything is flat. So the next thing we need to do is take this and unroll it. So when you've got your thing connected to itself, unroll surface is the command, unroll SRF, and hit enter. Make sure you're checking your command line up here. It's going to give you a series of options. First being whether we want to explode it or not, the second being whether it has labels on, and the third being whether we keep the properties or not. So the first two are what we want to control. So explode means that when this thing flattens out, do we want all of the pieces to be separate from each other, or do we want it to stay, do we want the edges to stay together where they can? So we're going to look at it not exploded first. And we want labels on. So labels are going to tell you, when you have this thing that's connected together, you know what point goes to what. But when it's all laid out flat, it's not going to necessarily be clear what edge goes to what. So it's going to put a little label on the edges so that you can match them back up together. So I'm going to set explode to no, labels to yes, and hit enter. And you can see that it's unrolling this surface onto the ground plane, and it's numbering all of the edges. So 13 goes to 13, 21 goes to 21, and so on and so forth, right? So this was super easy. Back in the day, you had to do this manually. It was a total pain. And you can see that where the kind of geometry gets a little bit more complex, it's going to put a gap between things, or, you know, you guys understand three-dimensionally how this is working, right? It's laying it down as flat as possible. So this is kind of what we need, not exactly, right? These numbers are right now parametric elements, meaning that we can click on them and change the number, but they don't really have a physical form in Rhino, which we're going to need if we want to laser cut them. Did everybody get unroll? Everybody who had something get unroll to work? Yep. And you can see that it referenced the original shape, so that you could go in and see, you know, where side 3 is in the original form. Okay. So I'm going to take my original poly surface and hide it, and I'm going to take the group of numbers and hide it, and that should be it for now. Everything else is kind of connected to each other.
If her selection keeps deselecting, is it because she's got one panel that's not
Okay, so moving on. If we want to be able to laser, guys, let's pay attention. Sorry. If we want to be able to laser cut this, we need to turn these text dots that they're called in Rhino. Like if I ungroup these and I explode them, you can select one of these dots individually, and that's what it's called, right? It's called a text dot.
you want us to select and explode them?
Yeah, so you can select them, you can select the group and ungroup it and then explode it. And now you should be able to select each panel or each surface individually and each dot individually.
So you
Explode and ungroup, doesn't matter which order. And then we need to separate these out. We want the text on a different layer than the surface. So we're going to edit, select objects, surfaces. There isn't a select objects for text dots, so we have to select what's not the dot and then turn it and invert it. So make sure that everything else is off. You want to just be working with surfaces and dots at this point, where everything else is hidden. So we've selected the surfaces, and then I'm going to select objects, invert, and that's going to select the dots for me, right? So I don't have to go through and individually click on them. And then in my properties box, I'm going to put those on the text layer. So edit, select objects. You want to select the surfaces, and then edit, select objects, and invert. So it's going to select the opposite of the surfaces. And then when the dots are selected, put them on the text layer. So now I can control those separately.
And then you just go over to the
Into properties with the dot selected, under properties with your object selected, under layer, you can change the layer. Okay?
and we want the dots under the text one?
Dots into text. Okay. Yep. Uh-huh. Too many surfaces on it? Okay, so there's no magic Rhino command to turn text dots into text objects, but we went on to the Rhino/Grasshopper forum, and somebody has made a really lovely script for us. So we're going to jump into, not only are we visually scripting with Grasshopper, we're now actually scripting with Rhino. So under tutorials, stretched volumes, sorry, I don't know why I can't move this over. You will have Grasshopper definitions and Rhino script files. Open up the Rhino script files, download it, and then unzip it. And in there are a series of RVB files. There should be 3 of them. It should look like this. Right, they should have an RVB extension. Divide curve to dashed line, text dot to text, and text to text objects. So I'll give you a minute to do that.
Now, on our, when we exploded and unrolled it,
Mm-hmm.
it unrolled it, so we have our original and the unrolled. Do we want to move all the text dots on the original as
You want to
well?
hide all of those, the text dots and the original.
And properties.
On the Canvas site, under Files, Tutorials, Video Tutorials, Stretched Volumes, and then Rhino script files. Okay,
And is that under Dan's or yours?
mine. I'm not on Dan's. Okay, can we move on? Did anybody get things did you get anything unzipped?
So are RVB files not Grasshopper files?
No, GH is Grasshopper, RVB is Rhino script. Okay, so to get those to work, and you'll see what we're doing here. So under Tools, Rhino script, I'm just going to tell you to open the Edit one for a minute, and you'll see what Rhino script is, right? It's basically an interface that looks like a regular computer programming interface. In here, you can make your own program if you know how to code everything, or you can look at some of the ones that are already written. And you can also, these are all of the different kind of elements and commands in Rhino. So you can go in, if you want a block description, you can go in and see what the parameters and returns are for the script. Don't worry about any of this. I just wanted you to see what it is that we're actually doing in here. So you can close this editor, and under Tools, Rhino script, you want to load a script. I'm going to delete all of these that I loaded earlier. And I'm going to add a new script to this. So in here, it'll bring me, you need to navigate to wherever you unzipped your script files to. And I'm going to open each of these three that I gave to you. So text-to-text object, add another one, text dot to text, and then add another one, the divide curve to dash line. So I'm just clicking add every time and clicking on a different script. When you're ready to use one of them, you're going to load them. So I'm going to start with the text dot to text. That's the first step that we're going to do. We're going to need to run two different scripts. One to turn it from a text dot into a text object, and one to take that text object and turn it into an outline, a vector of the text. So I'm going to click on text to text, text dot to text, hit load, and it's going to bring me back into Rhino having started that script. It's asking me, it's prompting me up here in the command line to select the text dots. So because I have them on their own layer, I'm going to right click and select objects, and then hit enter. It doesn't look like it did anything, but what it really did was make a really tiny little number 2 underneath this text dot, right? So if I try to click on it, you can see that I now have two different options here. You can do one of two things to keep your information organized. One is that you could have selected the text outline layer first, and it will make the new text elements on that layer. Or you can go into edit, select objects, and text, and it will select all 62 instances of text that I have, and I can put them on the text outlines layer and turn off my text objects. To change their size, could somebody close the door in the plotter room? To change their size, you can select all of the select the objects. Thank you. Select objects. You've got your 62 text elements selected. If you go into the text properties, you can change their height to like 6 inches, and now you can see them in my Rhino file. Right now they're there, right? You can see them. And they're not dots anymore, they're actual text. You can make them as big or as small as you want. I'm just going to make them big now for visibility's sake. These are still editable text, so if I click on it, I can still change the number. And unless I want to engrave all of these, I want to turn them into outlines so I can actually use them as vectors. So the second script, the second Rhino script, run. I actually need to load Rhino script load. I want the text to text object, and then I want to run it. Tools, Rhino script, run. Text to text object, hit OK. So it's asking me for the text to convert to geometry. So again, if I have it on the right layer, I can select the objects and hit enter. And it'll go through and turn all of these into outlines. Right? Does that make sense? Yes? Given time, you can follow along with that? Okay. So there's unfortunately no automated way to make sure that all of these, or at least not any automated way that I know of, to make sure that each of these are in the right place. So you're going to have to make some manual adjustments, or so you can either put all of the text on top of the object, so that when you cut it, it's scoring it into the surface of the material, or you can put them all to the outside and use your leftover material that you're cutting this out of as kind of a template, so you can refer back to it if you don't want the numbers to be on the actual object. This makes sense so far? So we've unrolled our surface, and now we know which sides match up with which. The next thing that we want to do is perforate the surfaces, right? The reason that we didn't perforate first and then unroll is that if you unroll a perforated surface, it goes in and marks every edge of the perforation, and so there's millions of text dots, and you don't want to have to be dealing with that. So we have our surfaces. We can go back into Grasshopper now, right? and I can open up my other Grasshopper script, the perforations one, surface perforations, and hit OK. And in here again, there's a bunch of stuff. Do you guys have this open? Are you getting these dialog boxes? Anybody who does have it open, are you getting these yellow dialog boxes? It won't open. Okay. I asked Don to update it, but he's out today, so it's because the most current version of Grasshopper has not been updated on these computers. There's a service release that's come out that whoever made the Grasshopper file made it in. So if you make it in the most current, you can't open it in anything previous. So follow along, and we'll make sure those are all updated. On your personal computers, you should have the most current version. So if you don't have these yellow things, then that's the problem. I'm personally not sure why he made these as panels rather than sliders. So you can put in a slider and plug it in place of these panels if you want to have more control over it rather than having to click. So just follow the line to where it was before, and then you should be able to adjust here rather than clicking and typing. And you can change, if you right click on the slider name, there's a blank box up here. You can call this margin and just label it something specific so that you know which slider controls what. So assuming that we don't want to update all of these.
I'm sorry, when you connected that, did it disconnect the other one, or did
Yeah.
you disconnect it?
It disconnected it because I didn't hold down shift. So when you don't hold down shift, it overrides any previous connections. So in here, it's asking you for an input surface, it's asking you for a series of variables, and it's giving you an output. And in between this mess of stuff over here, it's taking a surface, it's dividing it up into a series of divisions based on the offset that you're telling it. It's reducing a certain number of those around the perimeter. It's putting a geometry at each of the locations, and then it's giving you all of the kind of perforation outlines as a result. The one thing I'm going to ask you to do is the original one that you guys got had a circular perforation pattern in it. And because there's so many of you and because you're going to be perforating so much, circles take a really long time to cut on the laser cutter. So we're going to go in and plug a square perforation in instead. And it's really easy. So you just go to the point. So this is what you would have to begin with. You don't have this polygon. You have a circle coming in from this component and plugging into over here. So all we're going to do is put a different one in its place, a polygon component. And the reason that we used a polygon instead of a rectangle is that it defines how, it depends on how it's made, right? So a polygon is going to take a center point and then a number of edges and go out a certain distance from there, which is the same way the circle was constructed. It had a center point and then a radius. And so we're using the same kind of structure, but just making a square instead of a polygon, or a square instead of a circle. So from this point, I'm going to plug into the P on polygon, and you guys can go back and see this in the tutorial. And the R is coming from one of these inputs over here. The hole size, which is basically the radius of the hole. And so you take that and you connect it into the R on the polygon component. And polygon is just here, polygon. So I've got a P, an R, an S, and an RF. So the base plane that we're giving it over here from the plane origin, the R is the radius, the S is the number of segments. So a polygon is anything from 3 or more sides up, so we can tell it we want it to have 4 sides and make it a square. And then it's giving us polygons as a result. So we're plugging in the planes, we're plugging in the radius from our own input at the front end, and then I'm going to make a slider that has that is for the number of segments, right? So I'm just plugging that in there. And you can see if I turn my Rhino or my Grasshopper geometry back on and set a plane for this to be perforating, you can see that it's making a bunch of little square perforations. And if I were to change the number of sides, let me just hide this, sorry. If I were to change the number of, you can't see that on the screen. Let me select these guys. So if you were to change the number of segments, you can see that it's turning it from a square into a triangle, into a hexagon, and a polygon, yeah. Hexagon and a 5-sided one. So I just want to set it at 4. And then the P from that goes into this RDiff, which is a region difference. Don't need to worry about why that is. So you take that into RDiff, and you also take the P back to this output down here, which is the curves. Okay? So you should be able to do that without any problems. And again, you'll have 2 versions of tutorials that tell you how to do it step by step. So at the end of the day, what I want to bake into Grasshopper, or into Rhino, is this curve output. So I would select this, right-click, and bake. And I'm going to put it on my perforations layer. So now in Rhino, I have these guys as individual curves. Right? So if I undo that really quickly in Rhino, the other things in here control the offset. So I'm sorry, it's hard, you can't, with the colors, it's not letting you see. There you go. So I've got my squares and I've got my surface over here. The other things that you're controlling over here, so the margin offset is how far from the edge it's going to give you, it's going to pull these geometries in. So I think Dan talked to you about, like, there's a structure behind the edges of the panels, so that's what this is giving you. It's giving you space for that structure before it starts perforating, so you're not perforating all the way to the edge. And so you can set that to, you can set this to, whatever number you want, and control how much further in from the edge it goes. The grid spacing is the center to center of the grid of the different geometries. So you can make that bigger or smaller, and again you can set a slider for it. So you can see my grid just got a lot less dense because I upped the spacing between the different elements. The rotation puts the grid at a 45-degree angle, so you can see rather than coming from a baseline and going up and right, it's going 45 degrees from that. And the hole size is the radius of the square. So from the center point to the corner, how big is it? So you can set this to bigger or smaller. The more perforations that you make, the heavier your file is going to be and the longer it's going to take to laser cut. So find a balance between having enough perforation and not taking 300 hours on the laser cutter to cut out each of these individual squares. Okay? Again, you want to bake this guy over here. So I'm going to take this and bake it onto a perforations layer. In Rhino then, so I'm going to hide the Grasshopper geometries for a couple minutes and go in and get my surface that I just hid. I would want to take this plane and split it with all of the perforations. So you can go in, you're going to have to go in and do this one by one in terms of the surfaces. So I would just reset a surface every time. Sorry, I made a bunch of copies of this. I was playing around with something earlier to see if it would be easier. So you just have one of these. You would go into Rhino and set a different surface, or set each surface individually. Set one surface. It's going to do your perforation for you, which you can see if I turn my Grasshopper geometries back on. And then you're going to bake that out onto the perforations layer. And then you're going to repeat the process for each surface that you want to be perforated. Are you perforating all surfaces? Yes? Okay. Okay, so you're going to go in and do that for each of the surfaces. There's not an easier way, unfortunately, to do it for all of them at the same time based on the way the script is set up, because your surfaces are all sometimes triangles and sometimes squares. The way that it's set up, you can't do them all at once, so you're going to have to do them individually, unfortunately. But there's not that many that it should take you too long. You basically just click a surface, set one surface, and then bake the outcome. Okay? And once you've gone through and done all of this, so let's pretend that I did all of these I'm going to turn off my grasshopper geometry for a minute and hide this. You can go in and split them all at the same time. So to actually perforate these, right now we just have a line drawn on top of a surface. There's nothing that's making that into a hole. So to actually perforate those, we would want to split, so S-P-L-I-T. The objects to split, I can pick all of my surfaces if I have them on one layer, so select objects, hit enter, and then I can select all of my perforations as the cutting objects and hit enter. And it's going to go through and split each of these things. So now I have a big surface and a little surface in between. If I go in and delete these, now my surface is perforated, right? I think there is actually... I don't know.
Is it helpful to do that since now that that could be on the same layer, so you have to change the like coloring for when you cut it, or?
We're going to have to do a next step to it anyway because we don't want to cut the surface, we want to cut the outlines of the surface. So we're going to turn these surfaces into outlines in a second. And then we can distinguish between inside and outside. I guess actually we wouldn't have to do that. You're right. You don't have to actually perforate the surface. No, you're absolutely right. That's just one more step. So you can keep all of the perforations as a separate layer if you want to save a step. And then we'll just turn these planes into outlines, and then you'll have both sets on two different layers. So, good point. Okay, so once you've made all your perforations, disregard what I said a minute ago. You don't have to split them all out. But you do need to turn these planes into outlines. So I'm going to take the planes layer, select all of these objects, and type in dupe border. And I'm going to put these on the cut layer. So while everything is still selected, or by having chosen the cut layer first, I'm going to put these on the cut layer. And you can see that my cut layer color is set up for cyan. Sorry, this gets hard to see. So I just double clicked on the layer, and cyan is a default as a layer color. You can also just go in and make sure that it has 225 green and blue. And then I can turn off my planes layer. So theoretically, this type of information could be what I take to the laser cutter. The only problem is that I have lines here that are connecting to each other that I don't want to cut all the way through, right? I want to perforate those lines, or I want to score them. So, next step is to take the cut lines and explode them. Problem now is that where two things were touching, I have two lines on top of each other, so I need to go select out all of the duplicates, edit, select objects, duplicate objects, down here at the bottom. I switched to my view, sorry. Set view, perspective. So it's gone in and selected anything that was a duplicate, and I can delete them. So I only have one number, only one line on top of each other. And that's one of the things that Chris was saying before. He had a couple of things where there were lines touching or things that were copies, and so it cut it twice. So you want to make sure that you don't have multiple lines on top of each other. Lastly, anywhere that we have a line that's connecting two things together that we don't want to cut, we need to put those on a special layer called perforations that we made earlier. So I'm just going to do a couple of these. So I'm going to select them under properties, or under here I'm going to right click and say change object layer. So these are now on their own layer. I'm going to make this a different color for now so that you can see the difference, but eventually I'm going to turn it back to cyan because I want them to be dashed lines. There are options in Rhino to control line types over here. We haven't really talked much about this, but you can make a line dashed or dotted, but that's only a visual change. We want to be actually physically changing the line into a series of discrete segments that can cut individual segments and then have a gap in between them. So we're going to use one more script. So under Tools, Rhino script, load, we want to divide curve to dash line and load that. And then we want to run it. You only have to load it the first time. After that, you can just run it. It'll show up in this script subroutine. So you're going to click on divide curve dash line, hit OK. It's going to ask you which curve to divide. And it's going to prompt you for a segment length and then a gap length. So like in Illustrator, where if you make something a dash line, it gives you a dash and a gap. That's what these two things are, right? So the first one is the dash. So I'm just going to set it to something big so you can see it. And the gap I'm going to set to the same thing. So that line has now been made into a series of perforated lines, right? So again, you have to do this for each line. And you have to set the number to that each time, unless you go into the script and update it, which you guys don't really want to do. 5 by 5. And so I'm going to have all of these dashed lines anywhere that there are segments that are connecting that I don't want to cut all the way off. Does that make sense? Okay. The reason that you would use it as a dashed line rather than a scored line or, what do they call it, an etched line, is that you don't know which way it wants to bend, right? You've got a surface and you've got all these facets. Sometimes it might want to bend this way, sometimes it might want to bend this way. If you score it on one side, it's going to bend well in one direction, but not the other. But if you cut it with a dash line all the way through, it will bend either way easily. Okay? The other thing to think about with this and with anything that you're setting up to cut on the laser cutter is that in Rhino, you're working with virtual materials that have no thickness to them, but when you're cutting something on the laser cutter, you're cutting something that has an actual thickness to it. So if you were to cut a sheet of paper, it would closely approximate what you're doing in Rhino. But anytime you give it a thickness, when you bend something, you're bending against the thickness of the material. So sometimes things may not connect as perfectly as they would if that material had no thickness. If you're dealing with thin chipboard, you should be okay. And we can talk further down the line if you want to start fabricating things more precisely and dealing with material offsets. That's way beyond the scope of what you're doing at the moment. So the last thing that you would do is go into the top view and set this thing up for cutting. So right now it's at the size of the actual building, right? So you don't have a laser cutter big enough to cut that. Do you know what scale your model is supposed to be made at? 3/8. Somebody do the math, or you can go in here. 0.375. So in the Rhino handout that I gave you is this whole fancy schmancy page units and model units. The 0.375 works, but actually doesn't work. For 3/8, we need to be able to divide this by a scale factor. Where's my 3/8? It's not on here. I have 3/16, but no 3/8. So it's halfway between 24 and 48, so it's 36. So 1/36 is going to be the scale factor. And what this is the model units times a conversion factor to convert it to inches, right? So if you're taking 3/8 to an inch, the actual units, a 3/8 inch unit relative to the number of total units in a foot is going to be 36. There's 36 3/8 in a foot. Does that make sense? There's 12 inches in a foot. There's 24 half inches in a foot. So that's the number you need to divide by. So in Rhino, to scale this thing down, I'm going to select everything and type in scale. Use 0, 0 as my reference. And then I'm going to type in a scale factor. I don't need to click any reference points. I'm going to type in 1/36. That's going to scale this down to hopefully fit on my, my sheet. But I know that because I have my grid set up in 1 foot intervals, that it's not going to fit on a 2x4 sheet. So I'm going to have to break it at a certain point. So I'm going to take this portion of it and separate it from the first. And maybe I can get this to fit on a 2x4, or maybe I need to break it up more. But basically you can draw kind of a virtual sheet of material in Rhino and see what fits on that sheet. If you split something at a line, or if you break it, you want to copy the number so that you can match it up. Obviously this isn't quite fitting, and you want to close it off. So I'm going to draw a new line that closes the end of this and make sure that it's on my cut layer. So I probably need to break this some more and make it fit on the sheet. But it's now at the size that I want to cut it at 3/8 scale for the laser cutter. Yes.
Would you break it more, or would you just rotate it to fit on the sheet?
Whatever makes it fit. Yeah. So this you could rotate. So you might be able to fit both of those on one sheet, or you might need 2 sheets. You might be able to fit part of it on there if you split this middle line in half. And all of these will have your perforations on them. So then the last thing to do, you want to keep your perforations on. So in the previous video tutorial, you'll just disregard the splitting and the duplicating the border and all of those things. You can turn your perforations onto a cut layer. You would want these to be on a magenta layer. Why is that? To cut first. Awesome. So you want your perforations, you want your dashed lines to be a cut line, so I'm going to turn that to cyan. It was just red for visual difference. I don't have anything on my score layer because I've made my perforations the perforation layer. And and your text you want to be an etched layer, so I want to make that red. All right. So this will score it into the text, but it's not going to cut out a 2-shaped hole in my object.
And that's what it would do if it's black, right?
If it were black as an outline, I don't think it would actually do much. But if it were blue as an outline, it would cut through. Or cyan, sorry. So you select this portion of the object for the page that it's on, and File, Export Selected. And you want to export it as a DXF, which is the AutoCAD Exchange file. You're going to name it something, so laser cut sheet 1. And then in here it will bring up your options. Remember that Chris said it needs to be earlier than 2007. Fortunately, Rhino only gives you 2004 as an option. So 2004 Naturals is usually what we use. And if you want to, just so that you know for future reference, you can go into Edit Schemes and you can go in here and see what it's converting, what it's converting from Rhino geometry to AutoCAD geometry. And something to know for the future when we do this for exporting things for rendering is that its default is to export surfaces as curves, which will really screw you up when you're trying to export a surface to be able to render. So if you just end up with the outlines, this is what the problem is for the future. Right now it doesn't matter, we're not exporting surfaces, but just know that for the future. So save and close, and then I'm going to export and just hit OK. And so then I can open up that DXF file in CorelDRAW on the laser cutter machine and cut it from there. Okay? A lot of steps. You guys can do it. I know you can. And then your portion of the process is to put it back together, right? As a shell.
On the cutting board, can we search the surface of the cutting of our cutting surface?
You should leave an 1/8" border more so for material inconsistencies than for laser cutter ability. An 1/8 or even a 1/16 should be okay.
Will there be burn marks on the other side of it at all? Or since
Usually it's burn marks on the top side.
and since this can fold either way,
You would tape it on the top side. With chipboard, you shouldn't have a big problem, so I wouldn't spend hours taping it up. Do a test. Maybe the first person to go can do a quick test and see how much burn there is and whether it's worth the effort of taping it or not. There was something I was going to tell you. Oh, one thing to know though is that you're going to be cutting out your interior boxes by hand. Remember that those boxes are now, I guess they wouldn't have been in the same plane before I guess they are in this version of the file. You've got your skin and your box on the same plane, but now your skin has a thickness and your box has a thickness. So you need to compensate for that when you're building your boxes, right? You need to go in with the dimensions of the boxes. Does that make sense? You need to account for the material thickness of the skin.
Chipboard about a 16th or something, or 2/8.
Yeah, it's about a 1/16 if you get the thin stuff. There's different thicknesses of chipboard. Don't get the super thick stuff, get the thin stuff.
Okay.
it used to be called dime board, single ply, double ply, triple ply. I don't know exactly what the bookstore or Rules calls it here, but you'll be able to see. So it's either really thin, kind of thin, or really thick.
Why does laser cutter cut squares so much faster than circles?
Because it has to move its location based on a series of coordinates. And so a circle, every place along it is different. It has a different x and y distance, or different x and y coordinate, whereas if it's a line, the x is always the same and then it moves consistently in the y. Or
Also, I'm pretty sure I answered my question. Is there any way to actually to put it back together after you perforated it? Do like a rendering around to see where the white will come through?
yes, you can also,
You could just explode the surface and perforate it in place.
you could split the surface and then re-roll it back up. It would probably be easier though to actually, so the reason we didn't perforate it first was because of the unroll and the dots, right? You could go in and use the same perforations on the not unrolled volume and then perforate it there, which would be better for rendering. So it's kind of two steps, but one way isn't going to work for both. Other general questions about this? Do you guys feel like you have a sense of how to do this, at least, if not explicitly step by step? You can go back and refer to the video. Okay.
When will the tutorial be up?
As soon as it uploads. So, sorry, let me stop recording.